This video is a tutorial on color mixing. It's not a review of Physical Science Module 15. It is just a tutorial on mixing colors and how our eyes perceive color. I normally hand out a worksheet to do this, but I've decided that while we're on quarantine, we'll just do it this way, and hopefully this will be helpful to you. Now, remember that the additive color diagram shows the colors of light that our eyes can perceive. There are hundreds of colors that exist, but our eyes can only actually pick up wavelengths in the red zone, in the green zone, and in the blue zone. And then because these colors of light actually mix, we can perceive lots of different colors. The primary blue covers the short wavelengths of light that come in. The primary green covers the middle wavelengths, and the primary red covers the long wavelengths of light that come in. And when those three colors shine together and are mixed, we see white light. On the subtractive primary color diagram, we have yellow, magenta, and cyan as the primary colors. Remember that the subtractive colors are colors that are made from pigments, dyes, paints, and those colors are made because the pigments, the dyes, the paints actually subtract light waves. They absorb them and then reflect back certain other light waves. For example, yellow pigments will absorb blue light and allow red and green light to reflect back. Magenta pigments subtract or absorb green light and they allow red and blue light to reflect back. And cyan pigments absorb red light and they allow green and blue light to reflect back. When we mix yellow, magenta, and cyan together, we end up with black because they have at that point absorbed all the light waves. They're reflecting no light back. This shows the two diagrams that we're going to be using in this tutorial. They should look familiar to you because Dr. Wall used similar diagrams in the physical science book. We have here the additive primary color diagram and the subtractive primary color diagram. A physical science student shines a flashlight covered in red plastic wrap on the ceiling of the darkened classroom. Her classmate shines a flashlight covered in blue plastic at the same spot on the ceiling. Are the students experimenting with the additive or subtractive primary? Since they're using light, they are experimenting with the additive primary color. What color will their experiment produce on the ceiling? We're going to go ahead and pull up the additive primary color diagram, and we can see that when we mix red light with blue light, we end up with magenta. What color would they see if a third student shined a flashlight covered in green plastic at the same spot on the ceiling? So now we're shining blue and red and green, and we can see when the three of them mix, we end up with white light. An artist wants to paint a seascape from life. He needs to mix a variety of shades of blue to do so. Will he use the additive or subtractive primary colors to mix it? Since he's using paint, he's going to be using the subtractive primary colors. What two primary colors will he use to make his first shade of blue paint? In order to answer that, we're going to look at the subtractive primary color diagram. And we can see that blue is made by mixing together cyan and magenta pigments. So he's going to use cyan and magenta. A Girl Scout leader needs to mix dye for a tie-dye project she plans to do with her troop. In order to mix yellow dye for the project, will she use the additive or subtractive primary colors? Once again, she's using a dye, and when you use dyes, pigments, paints, you're using the subtractive primary colors. What primary colors will she use to make the yellow dye? Pulling up the subtractive primary color diagram, We see there that yellow is actually a primary color, and so that was a trick question. In order to make yellow, she will just use yellow dye. She doesn't have to mix anything else with the yellow. A Disney artist is using an advanced digital cartooning program for the project they're working on. They wish to create a lovely shade of yellow for the princess's hair. Will the artist need to use the additive or subtractive primary colors to complete this task? Since we are working with a computer screen, anytime you're working with a computer screen or a television screen, or anytime you are using a projector to project something up on in a movie theater, you're working with the additive primary colors. What primary colors will need to be mixed to create yellow on his computer screen? This time we're going to go ahead and pull up the additive primary color diagram, and we can see on the diagram that in order to make yellow, we're going to need to mix red and green light. Standing in an art gallery, an art lover is looking at a painting called Variations in Red. What subtractive primary colors did the artist mix to produce the red paint used to create this artwork? Since the artist used paint, they used the subtractive color diagram to mix that paint. And we can see on the chart that red is a mixture of yellow and magenta paint. And so that's what they used to mix the red colors. What color light is reflecting into the art lover's eyes as they gaze at the artwork? To answer this question, we're going to have to pull up the additive color diagram. And we can see on there that red is a primary color, and so red light is reflecting up into the art lover's eyes. Standing in front of a television, a little girl is singing along with the pretty magenta cartoon doggy. What additive primary colors did the television mix to produce the magenta color? So to answer this question, we're going to need to look at the additive color chart. And so we pull that up, and we notice that magenta is a mixture of red and blue light. What color light is shining into the little girl's eyes as she gazes at the cartoon dog? And this is the same question. In order to get magenta, we need to mix red and blue light, and so red and blue light are reflecting up into the little girl's eyes. A mother is reading a picture book to her child based on a popular television cartoon character. The character is colored a lovely shade of cyan in both the television show and the book. Did the picture book use the additive or subtractive primary colors to color the character? Since it was made using dyes, it used the subtractive primary colors. Did the television use the additive or subtractive primary colors to color the character? Once again, we need to remember that anytime we're talking about a computer screen, a television, a movie projector, it's using light. And so we need to use the additive primary colors. What colors are reflecting into the mother's eyes when she looks at the picture book? So even though the pigments that were made to produce the picture book used the subtractive color mixing chart, anytime we talk about light reflecting up into somebody's eyes, we need to use the additive color chart in order to answer that question. So we're going to look at that. And we notice that cyan is made by mixing green and blue light. So those are the colors that are reflecting up into the mother's eyes, green and blue. What colors are shining into the mother's eyes when she looks at the television version of the cartoon character? This is the same exact question. Blue and green light are reflecting up into the mother's eyes. I'm looking at shirts to buy for my summer wardrobe. Help me remember for my upcoming physical science test. So for these, it's going to be most helpful if we just stick to the additive chart, because if color is reflecting, then light is reflecting. So we'll go ahead and ask the questions and see how they go. What colors does a green shirt absorb? Now, when we look at the additive color diagram there, we see that green is a primary color. So a green shirt is absorbing both red and blue light. What colors does a green shirt reflect? Green shirts reflect green light. Next t-shirt. What colors does a red shirt absorb? Red also is one of the primary additive colors, and so it is absorbing green and blue light. What colors does a red shirt reflect? A red shirt will reflect only red light. What colors does a blue shirt absorb? Blue also is one of the additive primary colors, and so it is absorbing both red and green light. What colors does a blue shirt reflect? It's reflecting blue light. Now we're going to move on to the secondary colors on the additive chart. And the question is, what colors does a magenta shirt absorb? Now, magenta is made by mixing both red and blue light, and so the only color light that a magenta shirt is absorbing is green light. What colors does a magenta shirt reflect? It's going to reflect back that red and green light. What colors does a cyan shirt absorb? Once again, cyan is a secondary color on the additive chart. It's made by mixing blue and green light, and so it is absorbing red light. What colors does a cyan shirt reflect? It's reflecting that green and blue light. What colors does a yellow shirt absorb? Hopefully we're getting the hang of this now. Yellow is a secondary color. It's made by mixing red and green light, so it is absorbing blue light, and it is reflecting back red and green light. If I buy one of each color shirt and bring them into a darkened room with me, let's say for the sake of argument that when I arrive home I've had a power outage, so the room is darkened, but I have a flashlight available to use. Using the flashlight, I find my way to my bedroom and I lay out all my new shirts on my bed. Because being alone in the dark is boring, I decide to play with my new shirts. And the hint is that when we answer the questions, we need to stay on the additive chart. So we'll go ahead and put that up. And we'll start with the questions. First, I shine a green light on each shirt. Which shirts will reflect that green light? So just to make it a little bit easier, I'm going to go ahead and circle the colors that when I shine green light on them will reflect green light. And those colors are green and cyan and yellow. What color light will be reflected back to me from each of these shirts? Now the only color light that I'm shining on them is green light. We can see from the chart that yellow is made by combining red and green light, and that cyan is made by combining blue and green light. But I'm not shining red light on any of the shirts, and I'm not shining blue light on any of the shirts. I'm only shining green light. So the only color light that can reflect back up from all three of the shirts, regardless of their color, is green light. Which shirts will absorb the green light and not reflect it back? That's going to be the shirts that are left there. We can see that the red, the blue, and the magenta shirts are going to absorb green light and will not reflect it back. What color will those shirts appear to me? Because I'm shining green light on those three shirts and they absorb green light, they're going to appear black to me. Next question. I shine a blue light on each shirt. Which shirts will reflect that blue light? Once again, I'm going to go ahead and circle the colors on the diagram that will reflect blue light back at me. And those three colored shirts will be blue, cyan, and magenta. What color light will be reflected back at me from each of these shirts? We notice on the chart that magenta is made by combining red and blue light, and cyan is made by combining blue and green light. but I'm only shining blue light on the shirts. So regardless of the color, the only color that can reflect back at me is blue light. Which shirts will absorb the blue light and not reflect it back? Well, that's going to be the shirts that are outside the colors that will reflect blue. That's going to be the red shirt, the green shirt, and the yellow shirt. They're all absorbing blue light. So what color will those shirts appear to me? Once again, they're absorbing the blue light. I'm only shining blue light on them, so they're going to look black to me. And finally, I shine a red light on each shirt. Which shirts will reflect that red light? Once again, I'm going to put a circle around the colors that will reflect the light that I'm shining. This time it's red light. And I see that the shirts that will reflect red light are the red, magenta, and yellow shirts. What color light will be reflected back to me from each of these shirts? When I look at the chart, I see that magenta is made by combining red and blue light, and yellow is made by combining red and green light. But once again, I'm only shining red light on the shirts, so the only color that will shine back at me will be red light. Which shirts will absorb the red light and not reflect it back? That's going to be the shirts that are left there, the blue, the green, and the cyan shirts. Each of those shirts are made with dye that absorb red light and don't reflect it back. So what color will those shirts appear to me when I shine the red flashlight on them? They will appear to be black. Now we're going to move on to some questions that are more like the type that Dr. Weil asked in the book, the On Your Own questions, on the study guide, and that will appear either on tests or quizzes for this chapter. Suppose you have painted your walls red. One dark night you take a flashlight, cover it with green cellophane, and shine it on the wall. What color would you see? Assume the paint on the wall uses the subtractive primary colors to make this light. So we're going to go ahead and pull up the subtractive primary color chart because it was used to make the paint that's on the walls. But we're shining a green flashlight on the walls, so it would be much easier for us to switch over to the additive color chart that we've been using on the past few slides. So we're shining green light on the red wall, and I've circled the colors that will reflect back green light. They are yellow and green and cyan will reflect back green light to me. Notice red is not one of them, so when I shine a green light on the wall, it's going to look black because the red pigment is absorbing green light and not reflecting it. On the wall of your room, you've hung a poster with a bright yellow flower on it. If you shine a red light on the yellow flower, what color will the flower appear? Assume the flower was painted with dyes that use the subtractive primary colors, and once again, your room is dark. So we'll go ahead and put the poster on the wall, and we'll pull up the subtractive color chart. And once again, although the yellow poster was printed using dyes that used the subtractive color chart, we're shining red light on it, so it will be much easier for us just to stick to the additive color chart to answer this question. We're going to go ahead and circle the colors that will reflect back red light, and they are magenta and red and yellow. And so yellow is there. Yellow will reflect back red light. But notice that yellow is made by combining both red and green light, and we are only shining a red light on it. So the color that will be reflected back to us is the color red. A cyan dye is made of a mixture of substances that absorb all light colors except blue and green. If you took a cyan piece of paper and placed it in a dark room and shined red light on it, what would you see? Now the cyan paper was made using the subtractive color chart, but we're shining a red light on it, so we're going to go ahead and switch over to the additive color chart to answer this question. And we'll circle the colors that will reflect back red light. They are magenta, red, and yellow. Cyan is not one of those colors. Cyan pigments absorb red light, and so when we shine the red light onto the cyan piece of paper, we're going to see a black dot. What would you see if you shined a green light on it? So we'll go ahead and circle the colors that will reflect green light on the additive color chart. They are yellow, green, and cyan. Cyan is one of those colors. But looking at the chart, we can see that cyan is made by combining blue and green light. And we're not shining any blue light on it right now. We're only shining green. So the color that is reflected back up to us is going to be green. That's the end of our tutorial. Hopefully you found it helpful, and hopefully you will be able to more easily answer the questions that Dr. Weil asks about color mixing and how we perceive color.